Hello, I am Saket from A section AIML final year. My topic in deep neural networks is machine learning. So let's dive into the topic on what is machine learning. So, introduction to machine learning. Machine learning is a subset of artificial intelligence focused on enabling computers to learn from data. So basically, what happens is nowadays all the machines and all the automated vehicles or automated task completing machines, they're all working with the help of machine learning. So it involves algorithm that improves automatically through experience. Machine learning is widely used application in applications like speech recognition, recommendation system, and autonomous vehicles. So what happens is there are different type of learning: supervised, unsupervised, and reinforcement learning, and semi-supervised learning. So first we will collect a data set. That might be any data set which depends upon what work we wanted to do. Suppose I wanted to work on predictions for shopping clothes. So in which month or in which year what type of cloth people are more likely buying. So I wanted to predict this. What I will do is I will collect a data set which is related to shopping clothes. So first I will clean the data set, because data set may contain null values or noise or any other unrelated data which creates overfitting. Mm, so overfitting, underfitting, any of these when happens, the prediction might not be very accurate. So to make the predictions accurate, first we need to clean the data, remove null values and unwanted noise. After cleaning the values, we will process the data. We will process the data and all structure and organize the entire data set. And now we will split the data into training and testing. Suppose the training is 80% and test no, the training is 20% and testing is 80%, or any percentage you wanted to split. You need to split and create a model. You need to select a model of algorithm on which you wanted to train for accurate predictions. You need to select a model and train the model, train the entire data set to the model. So after training the entire data set, now you will test the data set. So in training, what it does is it learns from the data set. It learns from the past experiences present in the data set. So it learns. Then what it does next, you need to do testing. You need to ask questions. Suppose if I ask in the year of 2025 which product people are buying, like which color cloth people are buying. Suppose example, if the answer is blue, so the machine learning algorithm, the model predicts that the color is blue based on the past experience. In this way, machine learning is widely used in applications. Type of machine learning: supervised learning uses labeled data to train models for prediction. Unsupervised learning finds hidden patterns in unlabeled data. Reinforcement learning trains agents to make decisions by rewarding desired behavior. Example for reinforcement learning is a machine which was created to play chess. So in reinforcement learning, it learns from the feedback surround, and the action depends on the action of the opponent. Suppose if I am playing a chess with a machine, if I moved one on the board, so depending on my action, the machine will take a decision, and based on that it will move. And if the move is right, I will give a good feedback. If it is bad, I will give a bad feedback. When I give a good feedback, it understands that the move which I made is correct, and next time I should work like this. If the feedback is not good, then it will it so based on this, it will learn, and it will predict the decision. Supervised learning algorithms. Common algorithms include linear regression, decision trees, support vector machines, and these methods you are used to for tasks like classification and regression. Their success depends on the quality and quantity of labeled training data. So let me tell you some explanation on what is support vector machine. Support vector machine is a line. Support vector is a line. So imagine there is a plane, and on plane there are different data points. Each data point is a value, and the support vector line is passing like this. So whatever the values, whatever the data points closer to the support vector line, those are the solutions, those are the decision values, those are the outputs of what the decision you made. Support vector machine, whatever the data points are closer to the support vector line, they are the data values. So in this way, supervised learning algorithm works. And unsupervised learn algorithm, clustering techniques and k-means and hierarchical clustering groups and cluster group similar data points, dimensionality reduction methods like PCA, principal component analysis, simplify data while preserving important features. These algorithms help covering underlying structure in data without pre-existing labels. So example, what is k-means clustering? K-means clustering is a point. Suppose if you are taking three cluster points 0, 1 and 2, whatever the data points closer to the cluster value 1, they are considered as one category. Whatever the data point are close to the cluster point 2, they are considered as another category. In this way, unsupervised learning algorithms will categorize the data points based on the closeness to the cluster points. K nearest neighbor means the data point which is nearer to the cluster point. In this way, the algorithms help uncover underlying structure in data without pre-existing labels. Reinforcement learning basis. Reinforcement learning involves an agent interacting with an environment to maximize cumulative rewards. It uses concepts like states, actions, rewards to learn optimal policies. Applications include game playing, robotics, and adaptive control systems. Key concepts in machine learning. Overfitting occurs when a model learns noise instead of underlying patterns. Cross validation helps access how well a model generalizes to unseen data. Feature engineering involves selecting and transforming variables to improve model performance. Challenges in machine learning. Collecting high quality representative data can be difficult and costly. Ensuring models are interpretable remain a significant concerns. Popular machine learning frameworks are TensorFlow, PyTorch, and widely used for building and training models. Sklearn providing accessible tools for traditional machine learning algorithms. Future of machine learning, ethical AI development and explainability and becoming key priorities for researchers. And summary takeaways, ongoing challenges and innovations will shape the future impact of machine learning across industries. I hope you understood the topic. Thank you.